Yeah. Share my screen. All right, so there's our agenda for the day. And let me get rid of that there so no one shows up on the recording. Okay, so to start with, I'd like to utilize the chat in several different cases today. So just to give you a quick idea, I do actually read over what's in the chat. So if I ask you to put something in the chat, please put something in the chat. First thing I want you to think about is this concept of sustainability. Please write a definition for sustainability in the chat. Do that now. Give you a minute. If you blow. I know I've mentioned this concept of sustainability to you in the past, and every kind of generation, you see different buzzwords appear in every subject, really. And in environmental science right now, sustainability is one of the big kind of buzzwords and concepts and terms that you see over and over again. And one of the things that I would like you to consider is just our perspective living in the year 2020. And it's very different when it comes to the environmental sciences than when I was a kid. The concept of environmental science, ecology, conservation, those are relatively recent concepts. And in terms of science, those are relatively recent sciences. And so my mother lived to be 86 years old. She passed away a couple of years ago. And she grew up in the Dust Bowl of Texas during the Great Depression. She was born in 1931. No electricity in her home, no water, outhouse if you wanted to use the bathroom, not even a telephone. And so when she and her family thought of this concept of sustainability, well, they never really thought of it, but they did, just not consciously. So sustainability to my mother was actual survival. Okay, it was a daily struggle in that Dust Bowl environment to survive, and many people in that environment did not. They picked up and moved. The Dust Bowl of the 1930s represents the last great migration within our country, not individuals coming from other countries to the United States, but people within the United States moving to other locations. So when we think of sustainability, it's a little different. Okay, we're not struggling, well, most of us on a day-to-day basis for our basic needs, survival. Sustainability for us relates to our standard of living. And my standard of living is much, much higher than my mother's was when she was my age or younger. Okay, so I'm just one generation removed from an individual in my family growing up without electricity, without running water in the house, etc. I don't live like that. So when we think of sustainability, we think of our standard of living and whether or not our children can live in with the same standard of living as we do. So the other day when we started talking about pollution, we really have to think of pollution in a couple of different ways. There's the obvious, and that is a giant soda bottle um, floating down a river, garbage. Okay, the actual impact of garbage and pollutants similar to garbage. And then there's also this new kind of pollution that we can't see. So when during the presidential debates, you heard Donald Trump talking about this concept of clean water and crystal clean air. Crystal clean water, crystal clean air. That is a type of pollution, smog, acid rain, pollution that you can see. And then there's this whole category of pollutants that we can't see. And in that is this pollutant known as carbon dioxide and global warming. And so when we talk about sustainability, that's really what we're talking about. How do we live today, and can our children and future generations live like we do? So then, what role do we have in creating and maintaining a sustainable environment? And when we talk about environment, keep in mind we're talking about where we work, where we live, and where we play. So, how do we, or what role do we have within our own community? Small, it could be our household, it could be the city we live in, the nation we live in, on this planet. Different scales. What role do we play in creating and maintaining an environment that is sustainable? Yesterday, we visited this detention pond, and I told you that that detention pond is going to serve as an example of how, or the impact we can have on our community in relation to one essential need. And water, I think we all can agree, is an essential need. Now, in southern Wisconsin, surface water ends up being something that we utilize mostly for our leisure activities, rivers, streams, lakes, for fishing, boating, just sitting along the Memorial Union and enjoying a picnic. We use our surface water around here for mostly leisure activities. There are individuals in Wisconsin, cities that use surface water for the drinking water. And when we talk about surface water, we have to define a geographic area known as a watershed. And here's the most important piece of this term. When we talk about a watershed, very commonly, those watersheds are labeled with the name of a river, okay? But the watershed is defined by a geographic area. And the key with that geographic area to understand it is to uh, outline the boundaries of which define an area that drains through one common point. So within the boundaries of a watershed, all precipitation is going to eventually drain through one common point. Now, obviously, that's usually a river. This is an example of that. If you consider the right-hand side of the image, there's a peak here. And you can see very obviously precipitation that falls on that peak is either going to drain to the right or it's going to drain to the left. So that peak, that dotted line peak there, is going to define one boundary of our watershed. Everything within that boundary, all the way over to the peak on the other side, everything within that boundary is going to drain through this point right down here at the bottom of this river. And so normally we would give this watershed the name of the river that through which all of it drains. So in Verona, anybody know what watershed we live in? What watershed is do we live in Verona?
Isn't it the Sugar River?
Sugar River watershed. Very commonly, you look around Verona and you'll see little signs entering the Sugar River watershed. And so what that means is all precipitation that falls in and around Verona is eventually going to drain through the Sugar River. One of the things that this image very commonly will kind of bring up for kids is this continental divide. And people who have traveled out west, driven from Verona through Colorado, maybe even further, at some point you always pass a sign that says you are now passing the continental divide, and kids always ask about that. The continental divide is a point in the Rocky Mountains. It's a line, it runs north and south. And if you're standing on that continental divide, then whatever foot is on the east side of the continental divide, all precipitation from that point to the east, all the way to the Appalachian Mountains, drains through the Gulf of Mexico and New Orleans. Anything to the west of that line is going to drain into the Pacific Ocean. So it's a divide in our country that divides the direction the rivers flow, essentially. So we can take this concept of a watershed and we can actually apply it to a city. And that's kind of what we did yesterday. So an urban watershed is, again, a geographic area. It's within a city, but now we're talking about a manufactured drainage pattern, a pattern that is manufactured by the city around stormwater. And that stormwater is moved through gravity. We said that yesterday. And in some cases, the gravity follows the natural contours or the natural slope within a city. And other times, the city engineers can manipulate the flow of the water by digging these trenches down the center of a road. And so if you have a slope that is slightly uphill, you can dig a trench in the middle of your road and bury that pipe at an angle so that it flows against the contour. So an urban watershed might look something like this. Yesterday we were at Harriet Park. Harriet Park is this crescent-shaped little area right here. This big blank area of the map, that's the high school campus. It's blank because there is no stormwater drainage under the old high school, okay? And then you can see these lines with arrows on them, the little circles, lines with arrows, circles. You see elevations, 967.13. That's on one end of Harriet Park, 966. So there's about a 1 foot difference in elevation. The water is going to flow from this point down toward that point. So the reason that we examine this concept of an urban watershed relates to the type of pollution that we see very commonly in southern Wisconsin. We said southern Wisconsin pollution really is sediment. And that's one of the biggest issues in terms of surface water pollution in southern Wisconsin. It's the sediment itself, and it's everything that is attached to the sediment. And so if we understand our urban watershed, then we can start to look at methods to filter, clean, absorb that water within a given area. And we know within that given area where the water is coming from, okay? So if we look at Harriet Park, we have two drains that dump into Harriet Park, and we can see that this drain is going to drain this area here. This drain is going to drain everything in this area all the way over here. Okay, so it gives us a background into the city and which direction the water within the city is flowing and where that is all leaving. Ultimately, we're going to see in a minute, this is going to drain through the city and over to the Sugar River. So that's a watershed, that's an urban watershed. Those are two very, very important terms. Now, one thing about a geographic area is you can consider this at different levels. So we just said that we live within the Sugar River watershed, and that's a level, that's a scale. We can actually back that up and look at a larger scale of Wisconsin, and we can increase the geographic area and therefore increasing the watershed. Ultimately, the entire central portion of our country, bordered essentially by the Rocky Mountains to the west and the Appalachian Mountains to the east, are part of the Mississippi River watershed, okay? So yesterday when I asked you, where does the water go after it lands on some impermeable surface in Verona, the immediate answer was the detention pond. A slightly broader answer, a little bit further downstream, would be the Sugar River. And if we follow that even further, we could follow that all the way to the Mississippi River, which we'll do here in a second. So ultimately, the stormwater that we are collecting into our stormwater system within the city of Verona, ultimately is going to make its way all the way down to the Gulf of Mexico. On Tuesday, Ms. Danel is going to lead you through an activity that examines the consequences of that, okay? But that's something that I want you to keep in the back of your mind. Okay, so yesterday we took a tour of Harriet Park, and I asked you to try to imagine that space and the use of that space, the function of that space. And we said the sediment issue, sediment is an issue as long as there's energy in the water. And as long as that energy is moving, the water has the ability to pick up and transport particles, sand, dust particles, anything that is in the water. If you can slow that water down, remove the energy, then all that sediment is going to drop out. Hold on, everybody. Take a deep breath. I'll get a quick demo. Whew. Man, this is spur of the moment. This is a spur of the moment demo. Hold on, everybody. Stay with me. Stay with me. I'm getting it. Holy moly. It's gonna work. Oh, yeah. Stay with me, everybody. Hold on. I need some sand. Just need a little sand. All right. I threw a bunch of stuff in here. Here's our demo, everyone. Whew, that was close. Okay, check this out, everybody. I don't know if you can see this or not, but I have a beaker. At the bottom of the beaker, you can see there's stuff down there. If I want to get that stuff, the sediment, suspended in the beaker, I take my stirring rod and I begin to stir. Okay, now I can pick it up. So this represents the water moving through the pipes within the Verona stormwater system. Okay, imagine we get 2 inches of rain or even an inch, and that water collects on those impermeable surfaces, and it ends up being a lot of water, okay? Because what we're doing is we're taking all those impermeable surfaces, we're channeling the water into these 18, 24, maybe even a 36-inch pipe. That water is going to be moving really fast. So if I want to get that sediment to drop, I just stop stirring. The big stuff falls out really fast. The little stuff, it's going to take a little while, but if I come back to that in a few minutes, it's going to be clear water. So the detention pond functions as a place where we can dump that water, allow the energy to dissipate, the water spreads out, the sediment drops, okay? But here's the problem with a place like Harriet Park. Harriet Park is covered by like 2-inch high turf grass. So how much resistance does that turf grass really provide in terms of, a resistance for that sediment? If we get a big enough rainfall, you can watch the water move right across Harriet Park. Harriet Park fills up with water, and the water moves from the point where it enters the park to the point where it leaves the park. And so as long as that water is moving, it has the potential to move sediment and deposit it on the other end of the park into the pipes. And now it's on its way to the Sugar River. That can be a little tricky in terms of trying to imagine because, like yesterday, we only saw the river when it was empty. And so you got to see the river when it's full of water. So here's a quick example.
Hey, today is October 22nd. That is a Monday.
Ben.
It is about 1:35 p.m. and I am just on my way to Harriet Park. I'm just coming out of the school parking lot. I'm at the point where I can see the pond for the first time in my life.
I sent Ben about, this must have been 5 or 6 years ago already, to the pond one day during the school day. It was raining. I said, take your video camera. Here's a video camera. Go to the pond. And let's see what it looks like on a day when it was rainy. This is what it looks like.
Oh my gosh. This is awesome.
Lots of water. Okay. This is where the water comes out. And you can see the entire center point is full of water. And that water is moving toward the northwest. And it looks like a fairly wide, deep path of water, and the water is experiencing little to no resistance. So the idea that I had 25 years ago was to come in here and use a backhoe and actually dig a pond, okay? And then create 2 or 3 small ponds where the water could enter, sit for a while, pond up, drop its sediment, and then move on as more water was added. And the city of Verona was all for it. The only thing that they asked me to do was to survey the neighbors. And they said as long as the neighbors are fine with it, they would do it. Now, here's the thing. We had a parent meeting, a neighborhood meeting with my students were kind of leading it, and about 40 different neighbors from around Harriet Park showed up. And I would say about half of them were super into the idea. And then there were several that were not. Now, without answering, I want you just to think for a moment. What was the number one reason the neighbors did not want a pond wetland in this spot? Keep it in mind, everyone. In 1980, when this neighborhood that you can see in the background right now was developed, this was a natural wetland. This was, in fact, a pond. So really what we would be doing would be just restoring a natural pond. So if you think you have an answer, stick it in the chat and I will check. What do you think the number one thing that the neighbors were worried about if we created a pond? Whenever I drink from this, I've really been getting into these Clarburns. It's just sparkling water. And then I have on top of it, I have my Globe can cooler. So I feel like I'm drinking like natural spring water. Just imagine I'm in the mountains and I'm slurping up a little bit of ice cold water from the mountain stream. It's quite good. Okay, mosquitoes. I see it, and yeah, I'm watching the chat in my other thing here. Flooding was a big one, but it's temporary noise, yeah, but the big one was mosquitoes. And I want to address that for a moment, because normally what we do this time of the year is we go to the ponds. We have 3 or 4 ponds we're working on, and we take a sample of the invertebrates. We use what's called a D net, and we actually get in the water and we sample the insects that are living in the water. And as it turns out, if you're in a healthy ecosystem, a healthy wetland ecosystem, you don't find explosions of populations of mosquitoes. And so I want you to stop for a moment and think about why that is. What you see right here is actually the ideal breeding ground for mosquitoes. Mosquitoes only need a small volume of water, lay their eggs, the eggs hatch in the water, and then when they, after about 2 weeks, 10 days, they go through the larval stage, they pupate, they emerge as adults. And they can do that in a bird bath. Okay, you can find mosquito larvae during the summer just about anywhere you can find water. And I'll show you an example of that maybe next week, but I have a video of myself exploring the woods and I came across this little tiny body of water. It had tons of mosquitoes in it. What this lacks are all of the predators that eat mosquitoes. And so if you create a pond system with native vegetation and you have what we would consider to be a healthy ecosystem, then you see a stratification of organisms appear. And you have predators and you have prey. And if you can create an ecosystem that is healthy, then you have organisms that eat mosquitoes. This setting here does not have organisms that eat mosquitoes. So as it turns out, the neighbors were not that thrilled about the idea of a pond. So instead with the city, I did a project, a couple of other projects in different detention ponds. And in this space, we've been replacing the turf grass with native prairie plants. And so yesterday when I was out at Harriet Park, you could see those areas of natural vegetation. Those areas of natural vegetation, that represents probably 7 or 8 different years worth of small plantings. And every year we just dig out a little more sod and we put a little more prairie plant in. And so that process eventually will result in this entire area being covered in native plants. And the idea here, once you start covering those replacing the turf grass with native plants, there's 2 purposes to this. The first is to actually create a physical barrier for the sediment. So you can see on the left-hand side, the water is flowing unimpeded toward the drain. Here, the water has to pass through all of this vegetation, and this vegetation is going to hold anything that was in the street before the rainfall, leaves, sand, gravel, etc. And then more importantly, in some ways, the vegetation does two other quick things. Number one, the root systems with these prairie plants can be very extensive and go very deep into the ground. And so those root systems can augment the natural absorption of the detention pond. And so one of the concepts that I'd like to introduce you to is this idea of recharge. And this idea of recharge refers to what happens to the rain water that doesn't run off? Where does the water go when it absorbs into the ground? And is there a benefit to that? So we know 150 years ago, there were no impermeable surfaces in Verona. Okay, before development of our city, most of the water that would fall from the sky as precipitation would soak into the ground somewhere. And now we've changed that to include concrete, asphalt, roofs of houses, parking lots, sidewalks, driveways, etc. And we have to deal with all this water every time it rains. What we do is we send that water downriver. So what is the impact of that? Is there a benefit to actually keeping the water right here in Verona and allowing it to be reabsorbed into the ground? These native plants are really good at that. They also then can utilize any of the fertilizers that might be attached to the sediment that is in the water. So when we look at the turf grass, we have 2 inches of vegetation. When we look at the prairie plants and the other plants that are growing there, the wetland species, by the end of the season, you might have 6 to 8 feet worth of plant material. And that plant material has the potential then to absorb much of what we think of as the pollutants in that water. Okay, so take a quick peek here at the place where the water is leaving. I want you just to see that. Also notice this is not a huge driving rain. This is a relatively gentle sprinkle. And so again, when we talk about the volume of water that collects from these impermeable surfaces, these surfaces where the water doesn't soak in, it's a lot. What you have here is flow. And when you look at this picture here, you can see, of course, the bottle. That's a problem. But what's more important is look at all of this plant material and other stuff that is up against the grate where the water's leaving the pond. That is sediment. That's material that is on its way to the Sugar River. If the water's moving with any amount of force, then that water has the ability to pick up the sediment. What we want is still water. Look how clear this is already. And it's only been a few minutes. It's already clearing right up. So that's what we want. We want that water to leave still. Oh, there's Ben. Ben's doing a little rap for us. Okay, so with that video, I hope you have ideas now. So 3 years ago, when Dr. Gorell announced that we were going to be building a new high school, we had a year of planning and we had 2 years of actual construction. And I approached Dr. Gorell and he was extremely supportive. I approached him with the idea that asking him if I could work with the site design engineers to design the detention basin here in Verona, the system to deal with all the rainwater, precipitation, snow melt that would come off of the roof of the building, the parking lot, the football field, the soccer field, both of which are artificial turf, and any other runoff from the site. Could I work with the engineers to design our detention pond system in a way that was more sustainable than maybe what a traditional detention pond system would look like? And so I would like to share with you, I don't know, maybe not Tuesday. We'll probably have to do it after Thanksgiving. I'd like to share with you the result of that. And I do think it could serve as a model for how we deal with stormwater moving forward for our whole entire community. We also have a couple of other examples of that in Verona, Silent Street Pond, Wayland Pond, but the new high school is sort of the ultimate design because we had the privilege of starting from scratch. Okay. All of this is going to lead into chapter 14 on water pollution. So you should be reading through chapters 9 and 14 now while we simultaneously talk about this stuff. Okay, so there is one more video here. Let me just quickly show you this in like 2 minutes. I'm going to fast forward. This is a video that I made a few years ago. And this video, what I did is I took Google Earth and I just recorded a Google Earth tour from Harriet Park. So let me just quickly show you this. We're going to zoom in here on a raindrop that falls on a house that is near Harriet Park. So imagine a raindrop that falls right here. It makes its way over here. It then goes under the ground and it ends up in Harriet Park. So the water enters Harriet Park on this end, it leaves over there. And then from there, we zoom south of Verona to the Badger Mill Creek. You can see that little creek winding its way through south of Verona until it meets the Sugar River. The Sugar River then makes its way all the way down to Belleville. And this is important because there's a dam on Lake Bellevue. In Belleville, there's a dam which backs up the river. What happens when you back up a river? All the sediment is dropped. And then from there, it joins the Rock River to the south. And of course, the Rock River then dumps into the Mississippi River. So if we back up here for a second, you'll get an idea of this watershed. So we are way up here in the Sugar River watershed, but eventually all of that water drains through this big giant river, the Mississippi River. And notice it's all heading south. So this entire geographic area represents the Mississippi River watershed. If we head south, we're going to dump all that water eventually into, you got it, the Gulf of Mexico. This is the Mississippi Delta. Up here is New Orleans. And you can see where that water enters the Gulf of Mexico. You can see all the sediment that is dropped. That's what that is right there. So that's it, everyone. That is the watershed represented by this, this area. This is literally the water that falls on Verona. All right. So take a deep breath, everybody. Take a big, deep breath right now. I want to share one last thing with you. I'm just plowing forward, everyone. I know it's Friday. It's a long, is it Friday? Yes, it is Friday. I've talked a lot today, but I'm just going to keep plowing through. So take a deep breath, everybody. Deep breath, get a drink of water. I want to do 2 quick things with you, then we'll just be done. We can just say that we plowed through all this. Okay, I want you to check this little thing out here, everyone. I want to just cover quickly one thing here. I think I'll just do it this way. So this is actually chapter 3. And one of the things in chapter 3 that they bring up is this concept of an ecosystem boundary. And right now, if you follow the news, you're hearing a lot about the Arctic National Wildlife Preserve, also known as ANWR. The Arctic National Wildlife Preserve in northern Alaska is the biggest wildlife preserve we have in our entire country. It's huge. Alaska is a gigantic state, and the big portion of the northern part is considered wildlife area. It's in the news right now because, well, it's been in the news for probably almost 15 to 20 years because they discovered oil in this area. And President Trump, it's always been a wildlife area, so it has not been open to oil exploration. But President Trump right now is selling the rights to drill in that area. And so that represents a large area. And you can think that's good or bad, by the way, no judgment. And Yellowstone National Park is an example of an ecosystem boundary that is smaller than Anwar, but also really, really big. It's the largest national park in the contiguous 48 lower states. And then you have like Devil's Lake. Devil's Lake is our largest state park. Again, we're getting smaller, but still really big. And then you could go as small as Badger Prairie County Park. Again, ecosystem and boundaries are clear, but much smaller. And so sometimes when we talk about nature, we make the mistake, I think, of thinking of nature as occurring in these really large ecosystems. And with Harriet Park and the introduction of small scale nature, is there a benefit to that? Is there a benefit to adding a small scale ecosystem, even at the size of something like Harriet Park? Is there a benefit to nature for that? And is there a benefit to us? Can that provide us an ecological service? So when you look at this portion of chapter 3 and they talk about boundaries, I would like you to think about that and kind of redefine what an ecosystem boundary is and the scale of what an ecosystem is. And is there a benefit to small scale ecosystems? Whew, this is a big one. Okay, now everyone, this is really important. So like focus for 2 more minutes and we'll be done. What is the purpose of photosynthesis? What does photosynthesis do? This is one that you got to add a layer of sophistication to, and I want to work with you on this for 3 minutes, and then I'll stop talking, I promise. Just follow along for 3 minutes, everyone. Somebody put in the chat, what is the purpose of photosynthesis? Come on. Ooh, I like that. Turning sunlight into nutrients. Yes, sort of. That's the standard answer. When you ask students, what is the purpose of photosynthesis? The most common answer, to create energy. And that is important. But really, I want you to rethink this a little bit. And I want you to recognize this little compound right here, C6H12O6. Okay, this is a really, really important piece to this. This is called glucose. And if you think of photosynthesis as producing glucose instead of producing energy, then a lot of environmental issues, they become more easy to understand. So I have a stump here. This is a hackberry tree. I want you to think for a moment, where did this hackberry tree get the raw materials to build this stump, this trunk? This is the trunk of a hackberry tree. I cut it down a few years ago, and it was a big tree. It was in the wrong place. Where does the tree get the raw materials to build its trunk?
The environment.
In the chat, everybody, right now. Where does a tree get the raw materials to build its trunk? Everybody put an answer in the chat. Right now. Where does a tree get the raw materials to build a trunk? Right now. Do it, quick. No, it's not the soil. It is the air. This is really important, everyone. Okay. And this is photosynthesis. Photosynthesis in a plant creates glucose, creates carbohydrates. Those carbohydrates can later be broken down in the process of respiration to release energy. Okay. Respiration is the process that plants and animals and plants utilize to break down glucose, to conduct all the things that they have to conduct on a daily basis, all those things that require energy. But you can also string those glucose molecules together to create biomass. Trunks, leaves, stems, anything else that the plant needs to build to create its structure and body. And it doesn't come from the soil. There are micronutrients that come from the soil, but this comes from the air. This is important when we consider the role of carbon and carbon dioxide in global warming, and we talk about how we take that carbon out. When you see a giant oak tree that weighs thousands of pounds, that thousands of pounds of weight comes not from the ground, but from the air. Everybody, this is an important slide, okay? Make a note. Photosynthesis, important, very important. Yes, energy, but also biomass. And you got to rethink that. You got to add that biomass part to your way of thinking. Okay, I'm going to shut up now. Oh, sorry, that was a lot. I know.